Yeah, thanks everyone. So my talk is about data-driven metric development for online controlled experiments. 7 lessons learned. So this is work with co-author with my previous colleague at Microsoft, Alex. So this piece of work is also mostly done when I was working at Microsoft. So later in the talk, you will see lots of lessons there, lots of examples by using the search engine, about the search engine Bing. So however, actually, those lessons we shared, they are very general enough so that they can be applied in many different kinds of online services, not just search engines. And that's why now I'm working at Snapchat about metrics. Yep. So first of all, why metrics? I'm not sure like what's the percentage of people here have heard about the term metrics in industry. So if we talk about metrics, basically it's there's a like very famous quote by Lord Kelvin. Basically, it's, if you cannot measure it, you cannot improve it. So this also applies to our online systems. So for example, we have like search engine, or we have recommendation system, we have like new algorithms or new UIs or any new feature. How do we know it's better than the old version or not? So how to make the shipment decision? Then that's why we want metrics to help us to make the shipment decision. Then the question is, what kind of things we can use as metrics in those shipment decisions in real industry. Of course, one way is to use some people's opinion, like CEO's opinion, shareholders' opinion, and this may work sometimes, but as scientists or researchers, we think it might be sometimes too very subjective, and we want something more objective. So another way is to use data. Because this talk here is at KDD, so we are not talking about CEO or their opinion. We are talking about how to use data as metrics for us. Okay. So then the question is how we use data as metrics in industry. So generally speaking, there are 2 types of metrics. One type is called offline metrics, and the other type is called online metrics. So offline metrics, actually, I think many people should be very familiar with, as long as you are working on like machine learning problem or data mining problem or information retrieval. Basically, they're like ground truth data, or something like some data you collected, labeled the data you collected, use them as ground truth, and then you compare your algorithm against the ground truth, and you know, okay, the new algorithm increases like the bar 10% or 20%. This works perfectly for us to publish papers. However, in real industry, when you have like millions of users, like millions of data traffic every day, and you want to evaluate your new algorithm or new features in a very dynamic environment, and then this approach is kind of limited because you really don't know what the real users think about your new feature. So that's why we have online metrics. The idea of using online metrics basically is to test our idea based on real users in real time. So, and mostly online metrics, they are based on A/B testing. So basically, we divide the users into different buckets or different traffic, and then consider them in like 2 parallel universes, and then give them the new feature versus the old version, and then we compare, okay, whether like in the new universe or new feature, whether the users, they can give us higher click-through rate, more revenue, or more queries in our search engine. So that is called online metrics. So like in there are lots of, actually this is kind of like, nowadays it's like the standard of the industry environment. We test, we run like hundreds or thousands of A/B testing experiments to test our ideas and see how our based on the online metrics, we see, okay, oh, our new algorithm, new feature improves the CTR or improves like the increase the revenue. Okay, yeah, and this is like the focus of this talk. And then give you this like overview about what is online metric. Then first of all, we take a look at this term, which is called overall evaluation criteria. So basically, this is how we think the organization or the online service should use how it use online metrics for their business. So overall evaluation criteria is like actually is a term originally from Microsoft, and maybe in other companies they are called goal metrics or key metrics. So basically these are type of metrics used to help the system, defined to help the system move toward the success of the service or the business. So we draw this a figure shows that if you consider the success of the business as the North Star, and the cube is your service or your system, then metric or the goal metric, OEC, is a force that helps to push your system toward the North Star, toward the success of your business. Ideally, you may think it would be the best. We have like a force that can push our system toward the North Star along the dashed line. However, in reality, in real business, the issue is we really don't know where the North Star is. Then the metric is something, the goal metric is something that we try to have like basically give us as good as the approximation as good as possible to push the system toward the North Star. And in fact, that's why getting agreement on OEC in the entire organization is a huge step forward for the entire organization. Okay, so in this talk, basically we will share a few lessons we learned through the past few years at Microsoft about we work on metrics. For example, we will answer the questions like what are the good qualities that we want for metrics, how to measure the qualities of metrics, and how we develop metrics with good qualities, and many other questions. And we will share the lessons to answer these questions. Okay, so the first lesson is about define metrics for metrics. So as I said previously, we use metrics to measure the quality or the goodness of our system, or for example, the search engine or the recommendation system. Then the first question is, then how can we decide if a metric itself is good or not, right? We need it to push us toward the North Star, the success of the business. Then how can we know whether this metric is able to push our system toward the right direction with the right force? Okay, so then we have the following two qualities we really want for a good metric. So first of all is the directionality of a metric. So a good metric, especially for goal metrics, should have very clear directional interpretation that aligns with user experience and the success of the business in most scenarios. So in analogy, you can consider the directionality of metrics like the direction of the vector, the force, that we try to align it with the direction of the North Star, although in reality we don't know where it is, but we will try our best to align it. So that a good metric won't push our system like away from the North Star, right? So for example, like in search engine, session per user we consider is a metric with really good directionality, because with more sessions, then means that our search engine is doing good things so that the users, they are willing to come back and to use it more often. And the second quality, which is also very critical, is called sensitivity. So basically, because we use the metric to measure the improvement of our, for example, algorithm or UI design, then for the engineering teams or like the feature teams, what they want is to use it with limited cost within short time. They don't want to like have it tried it, for example, run the experiment for half a year and then see, oh, whether it is good or not, then that is too much cost, right? They want to have like, with, for example, only 1% or 5% of the total traffic and tried it, and after a couple of weeks, then they can see, okay, the metric shows it's good or the metric shows it's bad. So basically this is called sensitivity. Basically the metric is sensitive enough to detect the improvement of the feature. So in analogy, you can consider like this is the magnitude of the vector that is strong enough to help us with very fast iteration of the improvement of the product. So one example is in search, CTR may be a very good metric with high sensitivity because it's very comparing with, for example, session per user, it is much easier to improve CTR. Okay, then, so these two, they're basically like we think a good metric with these two qualities should be a good metric. And according to our experience, we found that in reality, it is easy to find a metric that have one of these two good qualities, but it is hard to find metrics that have both good qualities. So that's why finding a good OEC or goal metric for the entire, and have the entire organization to agree on this goal metric is really hard. And also another issue is in reality, no metric is applicable anywhere. So I will talk about it in more details, but basically you just think no metric is like can be applied anywhere, and there are, even we design the metric very carefully, it could break in certain special scenarios. So that's why for us who work on metrics or data science, it is very important to fully understand a metric, including its directionality, sensitivity, and applicability. Okay, and then the second lesson we learned, because previously we talked about, okay, these two, we want a good goal metric have these two good qualities. Then the second question is, how can we measure or evaluate these two qualities, right? Metrics, they we don't have, basically how can we find metrics for metrics? Then in our experience, actually already used at Microsoft, is we have two approaches. The first approach is we use we call validation corpus. So this is a set of high quality past A/B testing experiments that are reviewed by a panel of experts with high confidence about whether, okay, the past experiment was really good, show better user experience, or like show really like worse user experience, or they are really flat in many cases. So we call this set of experiments kind of like golden set to measure our metrics. And for example, at Bing, there is a tool called Matric Lab with like hundreds of labeled past experiments to measure systematically measure the new metrics, or to compare the metrics. This is something very useful. However, this approach may not be applicable for new products that lacks like historical data, right? If you have a new product, you don't have so many historical experiments, then how can we evaluate, okay, the goodness of metrics? So another approach is about downgrading or degradation experiments. So in our experience, we found that it is it is really hard for the feature team or engineering team to improve something. For example, to improve the relevance of your search result. But it is much easier to downgrade it or to degrade it. You know, just for example, just randomize the top 3 or top 5 search results, then it definitely downgrade the search results and can downgrade the user experience. But we definitely don't want to permanently screw up the user experience. So this is something we really want to control. But slightly downgrade it helps us to understand, okay, whether our metrics are able to detect such downgradation, right? So in our previous experiments, we also have done this kind of approach to evaluate our metrics, to evaluate whether the metric is sensitive enough or has the right direction aligned with our understanding of the experiment. Okay, so then the third lesson we learned is about understand roles and metrics. So previously we mainly talked about OEC or the goal metric. So you can consider it's just one or two most important metrics the entire organization, all the teams, they make commitment they use to measure the improvement of their algorithm or their new features. Then in reality, I think many of us know that in a dashboard, we usually keep track of hundreds or thousands of metrics for the online system. Then the question is why we want to have so many, right? We just have 1 or 2, then we use that to direct us toward the North Star. But in reality, we want hundreds of them, hundreds of other metrics, because many other metrics, they are taking some other roles in addition to the OEC or the goal metric role. So in addition to goal metric, one more important metric we call it is Gargoyle metrics. So the Gargoyle metrics, they are usually used to help guard against situations when the goal metric may give the wrong signals. So as we said previously, no metric is applicable anywhere. So there should, and in case they break, we really need to use some other metric to measure the system. And that's why we have Gargoyle metrics. And usually there are 2 scenarios we use Gargoyle metrics, 2 most important scenarios. The first scenario is to replace the goal metric when the goal metric are not applicable. So for example, if you use click-based success metric as the goal metric, basically means that you use, for example, click-through rate or something, use click-based metric to measure how users are, whether they are happy with your search result or not. Then for example, for the feature team who are working on improving the instant answers in search, right? Instant answers are those weather answer or dictionary or stock answer. Basically, you don't need to click anything. You see the result immediately in your search result page. So for those teams, the click-based success metrics are not applicable. So we should use some other metric as Gargoyle metric for these teams instead. And the second scenario is Gargoyle metrics are used to capture the dimensions of the user experience that the goal metrics are not able to measure. This is a little bit more subtle, but one example we can think about is the performance delay as a Gargoyle metric, because we know definitely performance delay is something we want to avoid most of the time. And however, sometimes, for example, you enrich the results in your page, and it takes some time for the server to load, to take some time to show the result. Then the performance delay will definitely show some negative. But in this kind of scenario, we just make sure that as long as the performance delay is not showing too bad, then it's fine. But on the other hand, if like it is showing, okay, there are significant performance delay, then this is something we should be aware of. Okay. And in both scenarios, we consider having clear directional interpretation for the Gargoyle metric is very important because basically Gargoyle metric, most of the time they tells us that whether the user experience is improving in this dimension or not. Okay, and another type of important role of metrics is called debugging metrics. Different from Gargoyle metric, debugging metrics, they usually help us to understand why some goal metrics or some other important metrics, they move and do not move. So one example here we show is the debugging metric for PCR. PCR is page click rate, something like that. So if you just compute PCR, then like there are many different domains on your like result page that they are clickable, right? And then you see PCR increase or decrease. Where you really want to more, if you really want to like dig more into this, how your new feature impact users' clicking behavior, you may want to like decompose your PCR into like different domains of PCR on your page, so that you make sure, okay, if PCR increase or decrease or stay flat, whether it is because some other position still clicks from like the original position, or really the PCR is like really users have more clicks. So that's the debugging metric. Basically, it helps you to understand why your metric moves or do not move. And especially debugging metric is very important for a special type of very important metric called rate metrics. Because rate metrics, for example, they are like CTR is a type of rate metric, click-through rate, or for example, you have like query success rate or session success rate. These are all rate metrics. And because for rate metrics, they have numerators and denominators. So debugging metric, they are like basically help us to keep track of both the numerator and the denominator of the rate metrics, and help us to understand whether when the rate metric moves or doesn't move, what's the reason? Whether it is because the numerator moves because there are like more clicks, CTR improves, or because there are less page views when CTR moves. So being sensitive is more important for debugging metric in this sense. Okay, so so then another lesson we learned is about decomposed metric sensitivity. So previously we mentioned that being sensitive is very important for metrics, but in reality we observe is that there are many cases that metrics they don't move. Even like we suppose we expect them to move, but they don't. And so for example, you have like a few new versions, and you have like metric 1, metric 2, and you see, okay, metric 2 moves less than metric 1. And then, like in this case, you really want to know is why metric, for example, why metric 2 moves less than metric 1, why it is less likely to detect the movement. So in order to understand that, then one thing we need to know is we can do is to decompose the metric sensitivity. So metric sensitivity basically has the two components. One is the probability for the metric itself, or for the user behavior, this type of behavior really moves. And the second component is condition on the user behavior really moves. Well, what's the probability for your metric to detect it? So two examples. One example is like, the first example is session per user. It is, in fact, we find it is very hard to move sessions per user for most experiments in search engine. And the reality we found is that it is insensitive because it is really hard to change users' engagement behavior within short time, within for like a few weeks. So even like, if in this case, even you increase the power of your traffic or for example, increase like from 5% to 10% or 20% of your traffic, it is still, you may still observe that the metric is very flat or very hard to move. But in contrast, another type of being insensitive is could be because of statistical power. So if in that case, then what you can do is, if you observe, okay, a metric doesn't move because of lack of statistical power, then what you can do is to, for example, reduce the variance, increase the traffic, or make the experiment time a little bit longer. The last lesson I would like to share is about learn from offline data. So previously we said that we hope that our goal metric, especially goal metric that align with users' experience, and the success of the business. Then in reality, you know that when users use our online service, for example, search engine, they seldom give us feedback about their experience of using it, right? They never say, okay, I'm happy with this search result. I submit give you some feedback, or I really hate it, it is frustrating. So they never give us this kind of feedback. Then how can we come up with like a metric that aligns with good user experience? The method we had is called learn from offline data. And this type of metric we have is called user behavior-driven metric, that we hope that they basically they're defined based on user behavior models, and we hope basically we try to make them have very high correlation with the long-term success of the business. For example, higher revenue, higher market share, higher user engagement, and at the same time they're sensitive and actionable enough for fast product improvement. So this is a type of metric we had in the search engine as well. So there are a few main steps, 3 main steps in designing this type of metric. So I will be very brief about it. Basically, in the model, at the first glance, you may find that, okay, these steps, they look very similar to like you have a user model for other applications like prediction, or have a user behavior model for like prediction, for recommendation. However, in fact, the user behavior model we learned for metrics, they have some very important difference from user behavior models for other applications. So here are two very, very important difference we want to mention, we want to emphasize here. One is first rule is to keep this model simple, because we don't want, so basically like metrics, they're used to measure the improvement of other teams. So it is very important for us to fully understand the metric itself. So we don't want to have it as a black box. So keep it simple is very important, and we want to make sure it is very intuitive and decomposable. So when the metric moves or doesn't move, we really know why. And the second very important rule is using exogenous features only for metrics. So basically metrics, they are used to evaluate the other teams, right? When they have some new features, for example, they have like, for the team who have instant answer, weather answer, and we want to know, okay, whether this really weather answer helps the users to makes the users happier. And however, we cannot use the weather answer in our metric model, because the weather answer is something the feature team, they can control. So this is called the endogenous feature. So we cannot use this type of feature so that the feature team can manipulate the metric. Okay, so because of time, summary of this talk, I shared some lessons, but I think the most important thing here is we want to have data-driven. We want many companies, especially those internet companies, they are data-driven. And here we share the lessons about data-driven techniques can be also used in the online metric development. And for online metrics, you can consider, maybe you can remember it like in this figure, in this analogy. And that's all about my talk. And thank you so much. We have like more detailed insights, and if you are interested, you can read our paper. Thank you.
Thank you. Really enjoy your talk. So having metrics is half the story toward making a good decision.
Yes.
I'm interested in learning about whether or not you have a philosophy or like a general framework for making a decision based on the metrics that you mentioned, and maybe also depending on additional factors that might affect ship or no ship decision for a given feature.
Sure. So one good example is at Microsoft, the search engine of Microsoft, Bing. So, hello. Yeah. So for example, Bing is a very, very metric-driven or data-driven organization. So all the teams, they use the Go metric to measure their work. Basically, all the teams, for example, they make commitment at the beginning, say, okay, for this quarter or this year, we want to move the metric like 5% or some percent. And so this is very strict, and basically in the end, like all the teams, what they see is like, okay, our new feature, for example, new algorithm moves the metric 5%, 10%, and claim that as the success of the team. So yeah.